With regards to our education and workforce development portfolio, our specific areas of support for integrated STEM is we provide support to educator professional development, information technology and engineering programs, out-of-school time and college readiness programs for high school and middle school students, enrichment and leadership development programs that focus on workforce development for all students, environmental education, early childhood literacy, and programs that support inclusion. And all of this embodying the STEM and STEAM support where we're really helping to provide a scalable approach for future careers for young people. Recently, as recent as last week, we made a public announcement with Newark Public School System and Central High School, which is an environmental magnet school in Newark, as well as Kane University. And this basically is a partnership where we are helping to develop a current curriculum, environmental curriculum, and also delivering mentors and guest speakers for special events and volunteer engagement. So we made this public announcement last week, but this is one that will be ongoing for quite a number of years. Here in the picture that you see, some dignitaries from Newark, including Newark's Mayor, Roz Baraka, and Superintendent Roger Leone. Another piece of our support, which is tied to the support for Central High School and the broader Newark Public School System, is support for Students to Science. Students to Science is a 501c3 model program in New Jersey that addresses the STEM needs of the public and private sectors and prepares students for 21st century careers and workforce readiness through authentic hands-on STEM education. The Newark Students to Science Technology Center is a national model in authentic STEM and urban community development. In 2018, they opened their doors here in Newark, and the PSCG Foundation provided founding support for the organization. With that support, there became a partnership with Newark Public Schools, the City of Newark, and other local dignitaries attending it. And we've also had quite a number of employee volunteers, both from the skill-based side and non-skill-based side, attend sessions with students throughout the course of 2018, 19, and the plans for 2020. And in that scalable approach, another piece that we're very supportive of is an energy career program at Essex County College. With that program, we provide the knowledge and skills training for disadvantaged young adults so that they could have increased chances of finding a job in the energy field. Their primary focus is on industry-wide aptitude tests for careers within our industry. And some of those types of aptitude tests include plant operators, power plant maintenance, construction and skilled trade testing. And these would be for future careers for linewomen, underground technicians, division mechanic, automotive technicians. So in addition to providing funding support, we also provide mentors and guest speakers to attend this program. Another example, and this is more for the middle school area, is a partnership that we have with Conserve Wildlife Foundation. Through this partnership, and you can see the link here above, it's a good way to get some additional information, but essentially it's providing support for STEAM-based wildlife programming that's aligned with the next generation of science standards to students here in Newark at 3 elementary and middle schools. And basically it provides hands-on support in wildlife, fishing, bird watching, components that provide a hands-on learning experience in environmental education for young people. And then another partnership we also recently announced is with Math for America, which is a fellowship program based out of New York, but newly supported in New Jersey. Math for America is a nationally recognized STEM education nonprofit, and the partnership that we supported was with 3 universities: Montclair State University, Princeton University, and Rowan University. And essentially it was for 3-year support for fellowship for math educators receiving a stipend to attend a supplemental program where they can learn through a 2-day seminar a more innovative approach to math education. So these are just some examples of how we're supporting integrated STEM in New Jersey. But as you can see, each piece is scalable, starting with elementary, going all the way up to educators. And so we really believe that through that mission and the mission of the STEM Leadership Alliance, we are helping to move the needle here in New Jersey.
Thank you so much, Maria, and it's wonderful to hear about partnerships and opportunities of what's going on within communities and just forging those relationships and how important they are to the students and to really helping to move forward with the agenda around integrated STEM. So thank you. So with that, I'm going to turn this over to our keynote speaker today, David Barnes, who's the Associate Executive Director for Research, Learning, and Development at the National Council of Teachers for Mathematics. And David has just been an incredible leader around integrated STEM and really being very thoughtful with the math and I think challenging our thinking, which is exactly what we need to be doing. Because oftentimes when we talk about STEM, we still look at it through this lens of science. So with that, I'm going to turn it over to David Barnes. And he's going to walk us through a presentation around the M in STEM. So, David, it's all you.
Thanks, Kelly. And we're not going to walk, we're going to run. So just so you know, hang on. I just want to first thank Kelly and the STEM Leadership Alliance and NBC Learn for the opportunity. One of the things that we see when I go out and visit a STEM activity, you see great people doing things, they're excited, and I ask them, can you tell me about the math in your STEM activity? And when I do that, the first thing that they do is there's a long pause, followed by, well, we measured, or we counted, or we did a chart, or a histogram, or we did a dot plot, or we graphed something. And then the conversation sort of ends. That's it. And what I would say is that there's so much more, that these ideas might be okay if you're sort of in third grade, but if we're getting into middle school and high school, we need to be doing a lot more. That when we think about math and STEM, these things are okay as a start or part, but they can't be the end. And so when I think about critical principles for math and STEM, there are sort of three big ideas that come out. One is that we need to maintain the integrity of the mathematics. The other part is that we need to talk about and think about effective instructional practices in mathematics and use what we know about research-informed practices to inform our learning in STEM. And the third part is we also need to tear down barriers. That mathematics and math in STEM, while it can support and promote students, it also has the opportunity to create barriers for some students, and we need to take those down. When I think about also protecting the integrity of the mathematics curriculum, you know, oftentimes the mathematics may not be deep. Sometimes we have sort of the shiny object syndrome, where kids are doing what I'll call fun activities, but it's not really clear what they're learning and that's going to help them in the future. And so that's one of the pieces we need to really think about. What is the mathematics? And so we need some clarity in that the mathematics has to be integral in a STEM program. That doesn't mean that every day you have to do mathematics as part of a STEM activity, but if you have a STEM program and it doesn't have mathematics, then it's not really STEM in our mind. And these actually come from NCTM President's message you can find online by past President Matt Larson. But it really is to say, if we're not doing that for our students, we're failing them. The other part is about opportunities. How, if we're investing all of this time in STEM activities, Can we do it in a way that we're in fact improving their mathematics learning, their understanding, and increasing their opportunities for the future? And as leaders in STEM and leaders in mathematics, it's really our responsibility to think about these pieces as we work on our STEM program. So where I'm going to start is a document that NCTM came out with in 2018 called Catalyzing Change in High School Mathematics, Initiating Critical Conversations, that really takes a larger look at the structures and challenges of mathematics in high school. And one of the pieces of that is, why do we learn math? And we would argue that there are three big ideas. One is to expand professional opportunities for students. That if they're doing mathematics, this needs to be the core, that we're increasing opportunities that they have, and that we're not actually putting them into dead-end courses. The second is sort of the utility piece. Can they understand and critique the world? Our world today floods us with data and information, and so mathematics helps us to understand that and critique what's happening. And the third we describe as experience the joy, wonder, and beauty of mathematics. And I think that one is actually a broader piece because it's a lot about students. To experience joy, wonder, and beauty, you have to build a positive identity toward mathematics. And we know that for many students from elementary school into middle school and then into high school, we see a neutral or negative feeling toward mathematics. And the sad part is that oftentimes it's a negative feeling toward mathematics. The case is that for even students that do well in mathematics, they might not have a positive identity about themselves in doing math. And the other part is about agency. How do we use math? Feeling like math is a toolbox that they can use. And in a STEM world, it's really clear that kids need mathematical tools to be productive and to expand their opportunities. So I hope you're chuckling, because if you think about rigorous and engaging mathematics in STEM, it's probably not this picture you see here. This is more the traditional, the I do, we do, you do piece, where students are recipients of that. And we know that in STEM, it needs to be different. And so I would argue, and we would promote, that we need ambitious teaching of math. What does that mean? And NCTM has defined these research-informed teaching practices that actually can change the way teachers teach and students learn mathematics. And in this, the focus of the work transfers from the teacher to the student. The teacher's goal is to create challenging tasks, high cognitive demand tasks, and then to support students in building their understanding and their thinking about it. It really is a chance for students to make sense. Too often in mathematics, the learning of math is more like a house of cards, that I just memorize it. And as I get farther and farther along, it gets more tenuous and more tenuous until it comes crashing down and I stop taking math. And that's a real concern. So we have a way to change that, and I'm going to talk about that in some settings here. And what does rigorous and engaging math? One of the things that sometimes I hear is that it needs to be fun. And sometimes teachers say we want to do a fun activity. We're going to do the M&M activity. And what I would argue is if kids enjoy what they're doing, that's important. But just doing things that are fun, they'll remember the M&M activity, but they have no idea about what math they were trying to learn. So we should think about rigorous and engaging. Rigorous, it's at the grade level for students. It has mathematics content and practices. It builds conceptual understanding and works and ends up with procedural fluency. So they have understanding and fluency, and that it makes sense in the world, that they're using their thinking to make sense. And then there's the mathematical practices, critical thinking, problem solving, reasoning, connections. All of those come. So that's mathematically rigorous. What is mathematically engaging? And for you to be engaged in mathematics, really at the core, it's about your thinking, constructing arguments around your thinking and your reasoning. Why does this make sense to me? And then also being able to consider and critique the reasoning of others. So how do I think about those pieces? How do I make sense of other people's thinking? So it's not being told, but it's really connecting those dots. And that's a community activity that teachers can engage in with their students. One of the things, and this is really about the equity piece, that mathematics education has a special place in education, that it often reinforces rather than moderates inequities in education. And this comes from OECD. This is actually something that's not just in the U.S., but worldwide, that oftentimes these inequities are reinforced by mathematics education. That's a huge issue we need to think about in STEM and as well as in STEM education and math education. So how do we make sure that we're not reducing opportunities and that we're giving opportunity to each and every student? With that, I am going to jump in and talk about sort of 4 different types of activities or opportunities for finding math in integrated STEM. And these come in various ways. So we'll look at some real data, passive solar house, water flow, and then I found an NBC Learn video that we can talk about. So I understand that we're all on mute, but one of the things that we do in math is think about notice and wonder. What do you notice? What do you wonder? So here's a graph, and you can think about what questions you would ask relative to this. So one of the things that people will ask is, well, how many units are on the bottom? What are we collecting data on? One of the things I'll notice is all of a sudden there's this big spike here. What happened at that point? What is that? And so what I can share with you, and this is actually real data, this is data that was collected from air quality sensors. And if you look closely at the pictures, you can probably figure out where it's collected at. In the lower right picture, in fact, in the back, you can see the St. Louis Arch. So this is air quality data collected in St. Louis over a 24-hour period from different sensors. All right. So then the question is, there's some more information. What do you notice or what do you wonder? And in this case, students can talk about the pieces. You know, in fact, the information is that this turns out to be air quality collected on July 4th, 2018. And this is real data from their sensors. So the question is then, what happens on that date? You can think about that, and then it starts to think about the impact. So what you're probably saying is, oh, the fireworks get shot off. So there's a whole range of other types of questions that you can ask about the data as you think about notice and wonder. And that's one of the core pieces that we want, is for students to ask questions, ask mathematical questions, and then it creates a reason for them to really start and think about how they could use the mathematics to think about that. When I saw this data, and I'll be honest, I have a son who has asthma pretty bad, I never really thought that what happens at the 4th of July makes that much of a difference. But when I saw this is really pretty significant. So there's some information there. All right. So I need to take a drink. The second piece is a lesson about model passive solar houses. And this is actually an activity that was worked and put together across 3 of the STEM education associations, ITEEA, ASEE, and NCTM, to work and say, if we think about integrated STEM, how can we work to put a lesson together that represents each of these areas? And when I say represent, you know, there's always going to be one of the STEM areas that is sort of the lead and other areas support, but they should have a presence in that. And as we were working on this with Steve and Jen and Stacy and Geraldine, you know, they sent the first handout out, and it had this in it. They pointed me to this page, and they said, look, see the math? And I will tell you that there was a long silence. And I said, well, I'm not sure. I see an equation and I see some graphics, but where are students actually doing mathematics? And it became a place where we could all talk about what it means to do math. And I think that's an opportunity in integrated STEM and in your places and institutions and schools and districts that we have to start some discussion. You need to have a chance to talk about what does it mean to do math and how could we do that across our various areas. So it's not just fill in an equation or here's a diagram or we measured or we did a histogram. One of the things that I did was to add some pieces in there that said, let's give some data where they can start to ask some questions. So here's some data about R value. When you add insulation and the impact it has in keeping a house warm. And so there's lots of questions in this, and this actually presents a model for students to start thinking about what's going on to do that. In this activity, the teachers, and we did this at the STEM Leadership Summit this past summer, we had teams of teachers, there we go, work and build passive solar houses. And in the lower right, you'll see sort of the setup. We had a heat lamp, and we had a gun that could measure the temperature. They were set under the heat lamp for a minute, and then we measured the temperature in intervals following that. And they worked to build, and they wanted to build a house that retained the most heat for the most time. And it's interesting. You'll see these houses. As you look at them, all of the rocks seem to be at the very top. And this is sort of one of the anomalies of this sort of setup, in that the closer you are to the heat lamp in this setting makes a huge difference, where a few feet or a few feet in a neighborhood doesn't really make a difference. A one-story or two-story building in a community doesn't get different sun as long as you're not in the shade of somebody else. So, but they were building that and working on that piece. And so one of the things that we did in this group, dove into this activity, but they had to do some readings. And then part of this was then to say, what's the mathematics we can take from that, and how do we build these pieces in? And so from that, here's the range of questions that you can ask. So talk about what amount of added energy is lost every 60 seconds. And the importance of this is really in kids in mathematics going from an additive structure to a multiplicative structure. Are they going from thinking about just quantity to thinking about the ratio or the rate of loss? That's an important idea that has to actually happen between elementary and middle school into high school. If students' models are only ever additive, or they add or subtract, and not in the idea of ratio, that really inhibits their learning in mathematics when they go forward. A second piece is about creating a rule or function that describes some feature. So I wanted them to create a rule or function to predict the temperature at a specific time. And they might be able to use the same rule to predict the time for a specific temperature. You'll see in mathematics, that's what we would call the inverse, but that, in their minds, I just want them to create a rule. In that way, they're using mathematics to record their thinking. They're making some conjectures, and it's also a way for students to critique their reasoning and think about and critique the reasoning of others. How do these fit? How do they work? And with that, oftentimes the focus is that you have to have a rule that's specific. It can have multiple parts, but whenever I do it the same, if I ask you for the same, say, time, what temperature, it has to give me a value, the same value each time. So it has to be a specific rule. In that way, the mathematics, and oftentimes we just do mathematics without any context, but this really reinforces that mathematics is recording our thinking. It's recording what we're seeing. So the next piece is a question of, if your solar house sat for an hour, what temperature would it be? You will be amazed at how many people say 0. And so, but the idea for this is really about things about an asymptote, and that actually the temperature is going to go back to room temperature, whatever that is. And so it's starting to see and think about that, and building in sense making in the mathematics that they're doing. The second part is they oftentimes want to do a second house. So they look at other people's houses, they want to do a modification. And so here we want to use their previous thinking about the rule, and they do their revised house. We collect data at 2 points, and then using their thinking on the first rule, create a rule for the second one. So it's applying that thinking. It's generalizing the mathematics to other situations. It's the same situation, so how can we use that to apply to this piece? And then see how it does in predicting their values. That's the important piece. If students actually create a rule, in fact, it predicts the next 3 values very well, they don't have to ask, is this right? They recognize that their thinking developed a rule that worked for them in that situation. And the last one is even about geometry. What shape of battery provides the highest short-term retention of energy? What shape of battery provides the best long-term retention of energy? So it's some of these things that they can think about. So there's a range of activities that can happen there. All right. I'm going to jump to the next one. This one is on water flow. And again, this was a collaborative effort. This time we also included NSTA in the activity, along with ITEA, ASEE, and NCTM. And we did this in November in the Philippines. And it really was to challenge them to think about water retention in their communities and how do different soils impact water retention and water flow. One of the things that we were learning about is that water flow in the Philippines is an important piece, some for controlling erosion, but also for farming in that. So we put together an activity where they had to think about topsoil, sand, pea gravel, boulders, and they looked to put these pieces together, and you'll see the combinations down there. This activity with the teachers, they're actually creating different mixtures to solve a specific problem, and then talking about that, collecting more data, and trying to build a better solution to their problem. With that, there's a whole range of mathematics that can come out of this activity. One is the ratio of materials. Ratios, again, are so important. What does it look like? And so rather than just saying this and that, being clear about different ratios. Looking amount of flow for a set time. There's also, they looked at the rate of the flow. That's, for some things, water didn't come out for a while and then all of a sudden it came out quickly. Changes in rate and related variables. This is also a place for looking at data. So you can have a wide range of classes doing similar activities, but then collecting data so that we can look across the data from teams. Building predictions, functions, and models. There's also some things about geometry. People started to talk about sand and soil and looking at the different ratios and what is the impact of sand within a soil. Does it help it flow through or does it make it clump together? Another piece is about slope and runoff. So how steep should things be? So does water run off or does water soak in? And so a range of mathematics topics that connected to the idea of water flow. All right. The next piece that I did, and our colleagues at NBC Learn sent me a couple of clips, and the first one I looked at was on football. There was a big football night last night, and this really focuses on the Pythagorean theorem and the path that a runner has to take to catch. The tackler has to take to catch the runner. And so what speed, how far, and if you take the wrong angle of attack, then you might not catch them. And so when I looked at the lesson, and you'll see they have this lessons tab, the lesson was actually tremendous in thinking about how do I think about the mathematics inside this. Students were asked, should we be able to ask scientific questions, explore science and math using Pythagorean theorem? So that's sort of the content piece. And then they did some simulated models of two players running for a goal line, recorded observations, and then tried to build explanations. And so in this activity, they actually built a ramp and were rolling marbles down a ramp at different speeds. And then trying to, once they could create that ramp, they then could figure out how to generate speeds by placing the marble at different places on the ruler. And then having to think about, depending on the speed of the runner and the speed that they were going to generate for the tackler, what angle do they need to take to do that? It really was an interesting activity, and one that's connected to some other types of activities we see in math and physics. But it really was a great piece for following up on that and had real connections to how they could apply mathematics in this setting. I often think it's helpful to say, what do you notice and what do you wonder? I mean, one of the things that you probably wonder is, does the tackler have to be faster than the runner? I mean, in every case they do. If they're slower than the runner, they're never going to catch them. But that's one of the things. Looking at the rates and being able to make those rates and apply them, create rules for their models, replicate and revise, record their observations, and use models to predict. Those types of things all fit into using mathematics to make sense of and then to apply it to that setting. With that, they're really, and I looked at some of the questions that submitted before, what makes integrated STEM work? And I think one of the things is really valuing all the elements of STEM, including mathematics, so that we're actually, as math people, thinking about what is it in science, what is in math, are there engineering and technology standards that we need to cover, and seeing if there's places for overlap at our grade level. And it's learning and applying what we know to build understanding. That is, in each of our disciplines, we're working to build understanding. Math, science, technology, engineering all have a different lens or a way of seeing the world, but also have a whole set of toolboxes that they can use. And collectively, I think there are opportunities to work smarter. It doesn't have to be the more piece, but there are opportunities where if we're working doing this together, we have more time, and the goal is really to have the students do more of the work, that we're not always explaining, but the students are making sense in building that, and we're helping them through supporting that activity. Next, it's about building connections within and between the areas. How do we think about and make sense of problems? In mathematics, there's a certain set of tools we use to make sense of the world, and how can we apply that and build that mathematical toolbox? It's also about thinking about our thinking. In the end, it should be about sense-making for the students, and then really being able to critique others' thinking. And with that, the working together and collaboration again comes in. And lastly, about increasing opportunities. Can we create students who see themselves as doers of mathematics and doers of science and technology and engineering? And that those tools that they have, that they have rich toolboxes to apply to solve problems. So with that, I might be a minute early, but there's my thinking on mathematics and STEM.
Thank you, David. As always, I think you provide such insight and overview, and I really love the examples that you were able to share as well. One of the questions, and it ties into this example piece, can you provide some insight or guidance in terms of where can people go to obtain additional examples and models of using math in the STEM projects? If you could, we talked a little bit about that, but if you re-emphasize that, that would be great.
So what I will tell you is that it's one of the areas that we're working on at NCTM is about math and STEM. We actually are looking to pull out some of our journal articles and books on those types of things. We do have an Illumination site that has some lessons, and some of them are actually tagged as STEM lessons, but we're working to get more of a coherent set of resources. What I do know is that there are a range of publications. One is called Stepping into STEAM that NCTM co-published, and I know one of the questions was about elementary. This really, early childhood and elementary, this is a K-5 book about what does STEM look like or STEAM look like in K-5. I'd suggest that as a resource. But I will tell you that math has been has been a little slow to coming to the STEM discussion. It's one of those interesting quandaries with sort of assessment and standards at every grade. Many teachers think we don't have time to do STEM, but the reality is that there's lots of opportunities where you can learn math and science and technology and engineering together.
Thank you. A question that came up was around the value of the typical high school math course, as opposed to more statistics and data analysis. What are your thoughts on shifting that norm in high school to better align with mathematical thinking? Where do you think this is needed?
So I think that one of the things is, and NCTM's publication, Catalyzing Change in High School Mathematics, puts out a strong statement that we need a core set of mathematics curriculum for each and every student in high school that then leads to a range of opportunities. Clearly, statistics, and I will say statistical thinking and looking at big data, data analysis, that type of work provides significant opportunities for students. And so we need to provide those opportunities for every student in a core pathway, and then provide additional opportunities for students who don't want to do the calculus pathway. They would like to do statistical thinking pathway or a mathematical modeling pathway. So I think, yeah, we have, if you look at Catalyzing Change and our essential concepts, we provide some guidance. And some states are starting to look at this for providing a common pathway for students that have a more robust foundation across mathematics and statistics.
Great, thank you for that. Another question that came about is that, and you gave some of those examples there about, mathematics involved in STEM, but how is training happening with mathematics educators to better integrate STEM into the other disciplines?
What I would say is it's all over the place, right, in our education system. I think that you are seeing places where there is more work and STEM is part of the teacher training piece. I think it's often challenging for early career people to do all the things that we ask for them to do coming out of training. So it's really imperative for institutions of higher ed, along with the schools and districts that they go to work to help teachers be supported in that. One of the challenges that we see, here is also about teacher tracking. Oftentimes, the teachers with the least experience are given the students with the highest need. And that's really problematic. What we really call is, where possible, teachers should be working together and finding opportunities to learn from each other and to build their expertise in a community. It should be less of a teacher lottery. That is that, in seventh grade, I might get this teacher that's really adept at math or this teacher who's struggling with it. That all the teachers at a school or a district should be at the same level, and it's working to have that professional support and community to get teachers in that place. But the other part, and I think for people in higher ed, it is actually sort of communications, getting out of our silos, looking for opportunities to work together and to not just cover standards, but engage students in doing meaningful teaching and learning across our standards and content areas.
And to go along with this, one of the questions was around, we hear all too often students saying, when are we ever going to use this? And this is not just related to math. This is in a lot of subjects, right? And especially when we think about elementary teachers and elementary principals that may not necessarily specialize in teaching math during college for their teacher prep programs. How do you suggest helping the current teaching force improve math instruction to teach a more applicable and conceptual-based mathematics?
So I would go back to sort of the rigorous and engaging mathematics. It's really about, I might be able to pull this up. We talked about ambitious teaching. And what I will say is that it's at a structural level. It should be at a school or a district level to say, what are our goals? And then think about what are problems or contexts that students could use, create high cognitive demand tasks. Tasks where students have to think and make sense of the mathematics in a setting. We know kids struggle with that, but the reality is that there's oftentimes much more information and much more connections they can make within that context to build their understanding and their fluency. And creating those types of activities then allow you to get into the discourse piece so that students are actually doing real problems and thinking about the mathematics of that problem along with their peers. So there's definitely some struggle that goes on, but in the end, they're seeing stronger connections with the mathematics. So if we can get rid of naked problems, but engage students in thinking about real mathematics, promoting reasoning and problem solving, that's sort of the focus.
Thank you, David. Maria, there's a question for you as well, so I'm just going to give you a moment just to get ready because I want to go back and ask David, another comment that or question that was being asked here. And so, again, I think one of the things I'll just say to everyone, too, is that again, continue to look at NCTM. They have a wealth of resources that are available. As we look at how do we keep math relevant, not these isolated skills, and continuing to think about this, I think, David, you gave some really, really great and concrete examples there, which are really helpful for folks. I'm going to flip over to the early side of STEM education, because one of the questions, too, was around how do we begin teaching STEM in early childhood education? And there you were talking a little bit about, you know, it's okay to do kind of that simple math and those, because those are the concepts that they're learning and building upon. But oftentimes I still think that when we talk about STEM, it still is viewed through that lens of science. And so we're trying to get that to be more of this expansion there. And would just love any of your thoughts around STEM in the early grades, and how do we encourage and emphasize for students to realize that STEM doesn't just happen only in a science context, but it really can happen in any class, including mathematics.
Well, and I actually think for young kids, math and science can come together. I think that oftentimes it's us that split it apart to say, oh, that's math or that's science, that there's ways to sort of understand and make sense of the world if that's sort of one of the goals of science. You know, one of the things that at the core for elementary kids, it should be about sort of making sense and recording their thinking. And oftentimes what mathematics does is gives them a way to record their thinking. And if we use that, the other part is about patterns and relationships. And depending on how they see different models for recording their thinking, different patterns or different relationships show up. And so it's those connections of saying that numbers on a page connect to something that I'm doing over here. And there, in fact, I can use symbols and math to tell a story. It tells a story of the work and the thinking that they're doing. Is really at the core of STEM in elementary school. That it's not about really memorization, you know, and sort of applying things they don't understand, but it's about taking their thinking and being able to use their thinking and use the tools that we have, the math, the symbols, to record it, to expand on what they know and what they understand. Does that help?
I think it does. And I think a lot of this is so important that we're not just isolating it on one age or one grade, but really thinking more broadly about this as well.
You know, we use the notice and wonder. What do you notice? What do you wonder? And that is an excellent way. I mean, what we want to do is invite students in to being part of thinking mathematically, or paying attention to the world, asking questions. All of these things are things that mathematicians and scientists do. Those are the types of things we want to do across our math and science at the elementary school.
Great, thank you. So just one quick question here, Maria, because I want to turn this over to Melissa, who's going to, from NBC Learn, to kind of help wrap this up for us and especially thank them. Maria, really quick, because I thought this was an excellent question, was we never hear about a volunteer coming to a math class, but math is incorporated into jobs every single day. And so what are your thoughts in terms of, if we're trying to make math relevant, how do we think about volunteers coming into math, maybe talking about the relevance of math, and you know, maybe it's with geometry, or maybe it's some other topic there that we could have a little bit more of a lens. If you could give a real quick response there, because I do want to get this back over to Melissa, so thank you.
Thank you. That's a great question, and we're 13,000 strong of employees of skilled. A majority of that is skilled based, and what I mean by that is field of engineers, folks out in the field restoring power, and so math is really critical to their everyday job. And so when we look at different volunteer opportunities, we try and target different areas of the business and really make it appealing for folks who can speak that language to students, because it is very specialized. It is something that you have to have that level of background in. And then for our general population of employees where there's volunteer opportunities, we tap into our finance folks and really, and also in other partnerships I didn't even mention, but like junior achievement and different organizations that bring that level of math to the table. We really try to sort of map out where our workforce is, what their skill set is, and how they can be supportive to some of these organizations, particularly when they're bringing that type of information into the classroom, whether it be direct classroom or out-of-school time programs.
Great. Thank you for that. Melissa, I'm turning this over to you. I want to thank David and Melissa, just help bring us home, and thank you, NBC Learn.
Yeah, thanks so much, Kelly. And I can't really put it any better than David did earlier when he was talking about the ways that our videos can really be a tool in an educator's toolbox for teaching integrated STEM. And we do see ourselves as a bridge between classroom and career. So while it's great to get students out in the real world and have them doing hands-on activities on a day-to-day basis, we like to think that our videos go some ways to make those experiences possible within the classroom setting. So when you come to our site and you see our Made for the Classroom videos, you'll see all of these series that we've done really with an integrated STEM mindset. And we've worked with the National Science Foundations, we've worked with NCTM, and we're really trying to both give students role models. We've done this 30-part series now on young, diverse engineers who are not only diverse in their identities, but really in the range of career opportunities that they showcase to students, and highlighting the ways that concepts and skills from all four of those disciplines do play a role in their day-to-day lives. And thinking even beyond just the STEM classroom, we have a whole collection of our math and statistics focused resources, because we know how important numerical literacy, financial literacy, all of these concepts are to our students as they interact with the text that they're reading in a science classroom, but even just the media that they're consuming on a day-to-day basis. So we think the approach of focusing on those essential math skills and seeing them present not only in the various scientific disciplines, but even in a humanities classroom can go a long ways to making really well-rounded and critical thinking students.
This is great, and just from seeing it, you can see there's so many resources and so much information, and I love the fact that you have everything there, from math and stats in the news to geometry, and so this even goes back to the earlier question that was talking about thinking about statistics and using that more frequently in the high school model as well. So again, I know we're at time. There was a ton of information. There were a ton of questions people were asking on the WebEx. People were emailing me. So it was just wonderful to see this dialogue. I just want to encourage everyone, this has been recorded. You can find this information on www.stemleadershipalliance.org. And we will be back next month starting to explore that engineering component that exists in STEM. So stay tuned. We'll continue with the newsletter. We'll continue sharing information. And we also just want to invite everyone to join the summer conference. That's July 12th to the 16th. And David, do you want to just give a quick plug for the NCTM conference?
Yes. Can you hear me?
Yes, we can.
So NCTM turns 100 in 2020, and we have our centennial annual meeting and exposition April 1st to the 4th in Chicago, Illinois. We would love to have you, a wide range of sessions looking back from what we've learned, but also looking to the future and engaging in STEM. Thank you so much.
Great, thank you. And you can always find more information about the NCTM conference on their website as well, and I encourage everyone to take a look at that. I want to thank all of our partners, TSE&G, NBC Learn, David Barnes and NCTM, and I just want to thank all of you for being great participants, and thank you for the questions. And those questions we didn't get to, we're continuously updating the website, and we're going to be posting the questions that have been asked and giving answers, and we'll be sharing that information. So stay tuned for next month, and I want to wish everyone a happy Tuesday. So thank you.
Thank you. Bye.